Thanks very much. I'd like to acknowledge and pay my respects to the traditional custodians of the land that we're holding this conference on. Okay, so just waiting for here we are. So I'm going to talk about Groovy. Why should you be using it in 2024? And now, it's slowly waking up. Of one of the people involved in the Groovy language, there's a whole pile of other people. 300 or 400 people have contributed to Groovy over the years. All the slide material and all the examples are all online, all open source, so you can go and check this out later if you wish. So why should we be using Groovy in 2024? Turns out it's a very, very productive language. It's got a lot of really great features, and it's very performant in many scenarios, and there's ways to make it performant when you need it to, and we'll be covering a whole lot of things. I'm going to kind of focus on a couple of the key points here: extension methods, operator overloading, and so on. I'll explain them as I go through, and these are kind of some of the points, if you're a Java programmer, things that you won't have that Groovy does have, and it's kind of nice. And it's ideas that have been borrowed from the Python world, the Smalltalk world, the Scala world, and sort of merged into a language. So we'll start off with extension methods. So what we have here is a little bit of code. The first 3/4, maybe 80% of that code is I'm going to use, it turns out to be Apache Commons Lang library. It happens to have a string utils class in it. And one of the methods in that utility class is a capitalize method. So this is a bit of code that'll actually download that library, put it on the class path, and then call that method. And so that's certainly what you're going to want to do for many things, but for the really, really common stuff, Groovy sort of said, why don't we put some of that stuff, build it into the language? And so in fact, on the last little bit here, foo.capitalize is one of the built-in methods. And it looks like it's a method on string, but if you go and look, and this is, Groovy uses Java classes nearly all the time, but it enhances them. So this looks like I'm calling the capitalize method on a string, but there is no string capitalize method in Java Lang string. So Groovy has these extensions. That's why they're called extension methods. And it's got a whole pile of these. So there's 2,000 of these things across 150 classes, and there's just lots of stuff that you're going to get a better out-of-the-box experience, or it's sort of the Python world calls this batteries included experience. So you buy a toy for your kids at Christmas and they open it up and there's no batteries there, and it's sort of a bit of a letdown. Groovy has just a whole lot of very, very useful things built in that are just there, and they're in there for free. One of the, and it'll wake up, the things I just wanted to give a shout out to is something that we've enhanced a lot in Groovy 5, and that's some of the array extension methods. So if you're a Java programmer, you're probably using the streams library a lot these days, and it's great. We use it all the time. Groovy fully supports it, and it's very, very common use to make use of it. But Groovy also has a lot of the similar sort of methods that if you're using streams, you're sort of familiar with the find, reduce, sort of set of different kinds of methods that you'll have. Groovy has traditionally supplied all of those for the collections hierarchy and everything else. So if you'd go find things, you'd collect them, you'd do all sorts of manipulation, and they're the kind of things you do these days with streams. What Groovy's done is said, yes, by all means go use streams, but we'll provide a parallel things that don't require you to set up the whole streams mechanisms, which when you use a stream, that's what happens underneath the covers. So I'm just going to run a little bit of a benchmark. And here I've got 2 bits of Groovy code. One's using the built-in array extensions, and one's using streams. And just to be fair, I'm going to get annoyed with the speed at which this is responding, so I might just flick over here. And to be fair, I'll show you the Java equivalent code as well. And I'm just going to run a little benchmark. Now, benchmarks, they're ways to lie about statistics, right? So this is a micro benchmark. Don't go insanely changing every single one of your projects to use this technology based on this one benchmark. Go benchmark whatever you're doing. But what I'm doing here is that there's a graph. The blue, the first two bars, are using the primitive array extensions that Groovy's got. This is for max, and there's a max abs, which is I want to find the maximum value in a list or in an array, and I also want to find the maximum value by absolute value. So if I've got -10, that'll be bigger than 8 because I'm going to ignore the sign. So we've got two benchmarks. One's the max by absolute value, and I've done it with the integer primitive arrays extension methods. Then I've done it in Groovy with streams, and then I've done it in Java with streams. You can see when I'm using streams, Groovy and Java are about the same speed, but the primitive array for integers extensions are several orders of magnitude faster. And you'll find that across a lot of the things. So if you're in a data science scenario, we've really done a whole lot of work to make that super efficient. So there's a whole lot of methods now that work without creating additional, if you've got an array, previously you might have to convert that to a list, run some sort of list processing method, then convert it back to an array or something. There's a whole lot of methods that don't create any additional data types, don't use any additional memory, don't do any boxing, so they're all super efficient, and there's a whole pile of those that have been added or improved. And now I showed you the 2000 that came with Groovy, but the whole point of this mechanism is that it's extensible and you can use it. So here we can create our own extension method, and it's going to be one that's going to extend files. And what I'm going to do is create a word count method for files. And so then once this is activated, anywhere where you're using a file, you can just call .getWordCount or .wordCount, which is sort of a property abbreviation for the getWordCount, and that'll work. And in fact, when I'm writing this extension method, I'm actually using other extensions. So the .text is getting the entire text out of a file. That's another extension method that's one of the built-in ones. So when I'm writing an extension method, I can use that. Now, the good thing about this mechanism is that this will be a global thing that's available, and you'll get full ID completion, full typing, and all the things that you'd want, depending on how you make use of it. So it's a very powerful thing, and so you can go extending your stuff. The second topic I want to talk about is operator overloading. And what that means is in your code, you can use the operators that you'd be familiar with operators when you're using maths. You're adding two integers or whatever it might be. You'd be familiar that some of these operators will work on strings. So if I've got a string plus another string, that'll create another string that concatenates the two strings. In Groovy, you can use any of those operators with your own classes. Okay. We could talk about other languages that you have customizable operators. Groovy doesn't. It just has that list there, but you can customize them to your own objects. Now we've gone and customized them to things like big integer and things like that, so you can have shorthand literals for big integers. And if you're using, this happens to be Apache Commons Math, it's got some matrix library capabilities, and it happens to use multiply and power as some of the methods that's in its libraries. And multiply and power happen to be the methods that Groovy supports as for its operator overloading. So you'll automatically be able to use matrices and use this shorthand notation. Now, if the library doesn't happen to use the exact same methods, you typically write a bit of glue code. The Apache Commons Math matrix library uses add instead of plus when it's going to add two matrices together. You typically write a bit of glue code where you write a plus method calling the add method. As of Groovy 5, the compiler will do the glue code for that sort of thing for you as well. So here, going back to that same matrix library, it turns out that it is using add and it is using scalar multiply. We can say, yeah, when you treat this as if it's operator overloading and do the renames on those methods for me, and it goes and does all the munging and makes all that work. So you can still use the old methods, which is the second last line of code, or you can use the shorthand. So here we're adding the unit matrix to itself. It's the same as doing a scalar multiply on that unit matrix. And it might seem like very trivial little improvements happening on these lines, but it kind of, when you combine it with all the other features, this is some code to actually do a couple. I'm using the Java REPL here, and I'm creating two matrices, and then I'm multiplying them and doing the power, the thing that we saw before. When you put that in a Groovy environment, add a couple of other features, this is the environment that you get. And so if you're a data scientist, do you want to see all of the variables and the type names and all that sort of information over there, or do you want to have this sort of environment? So it's like a MATLAB or R environment, but it's actually calling the same Java libraries that you're familiar with. And I'm also using a feature of the Groovy console that lets you customize the outputs. And so we've got a nice, pretty LaTeX generated matrix there as the output, rather than array 2D row real matrix, blah, 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 blah. So, I know which one I prefer, but up to you which one you prefer. Okay, now, extension methods add all those methods globally. There is a more fine-grained thing where I can add methods at runtime. And so I could add, depending on the situation, I might add different things or whatever it might be. So this is a very, very flexible way, and this is something that Ruby and Python sort of let you do. It's a very, very powerful mechanism. You've got to be a bit careful. So here I'm doing that word count again, and I'm doing I'm finding a resource on the class path and getting that as a file as well. It means I can write very, very short things, as you can see there, but you've got to be careful with this mechanism. I'll come back and talk about this mechanism a little bit later on. There's lots of other dynamic features of Groovy, and we don't shy away from being, so Groovy started out as a dynamic complement to Java. We don't shy away from the dynamic capabilities, but Groovy also now provides full static modes as well, and there'll be times when we might say, yeah, probably best not to use dynamic in certain scenarios, but we don't shy away from, hey, the scenarios where we do want to use dynamic, it is available for us to use. And so this thing here is a lifecycle hook. There's a thing called method missing. If I call a method on an object and it doesn't exist, it'll call into this method. So if I've got the static compiling stuff turned on, this won't compile because methods are missing. But if I'm running this in dynamic mode, it does compile, and I've got a hook now, and I can do magic things at runtime. And this mechanism is actually underpins a lot of the other features. So there's a dangling closure builder pattern is what you might call it. But here we're going to create a Maven POM file just by calling things. So I'm calling pom.project and then model version, group ID, the things you'd recognize those as the things you'd have inside a POM. And POM happens to be a markup builder. So I might think inside markup builder, I'm going to have some sort of methods project and model version. No, none of that exists. When I call .project and call .model version and things, they just get spat out as tags. And so the markup builder is just doing this. It's a way to generate markup, and I know that all my closing and opening tags are going to match, and can get a whole lot of other things right. And I can do it in a form that's more readable to a programmer might be more comfortable seeing a program-like thing, and I can have for loops and other things in there and build up a very large POM file if I wanted to. Okay, so swapping topics again. So I'm going to do a spattering of topics and then bring some of them together. AST transforms. So this is, if you've heard of Lombok project for Java, this is kind of like that, but instead of being a preprocessor, it's built into the language, and you can make use of it yourself. So here I'm creating a book class. It happens to have authors, a title, and a publication date. And it's got these @ things there, so they're just annotation references. And some of those annotation references are known by the Groovy compiler, and they're called AST transforms. And what they tell the compiler to do is inject extra code into the generated bytecode for you. And so for that, those 4 annotations there, the background of the slide is the equivalent Java code. And it's gone off the edge. It actually goes down probably below the floor of the stage here in a couple of these things. So it's quite a bit of code. So 600 lines of Java or 10 lines of Groovy. And it's not really about, am I worried about writing 600 lines of code? No, not necessarily. But when I go back to read this, which would I prefer to read? And I prefer to read the short one, and I know what what it's doing, and I know, oh, there's a design pattern to represent an immutable class, and there's a design pattern around how to sort stuff with comparators and whatever it might be. And the compiler is going to give me best of class for that design pattern. And if what's best in class changes over time, that'll get built into the next version of the Groovy compiler, and it'll generate different bytecode that might do smarter things in the future. And I don't have to worry about that because my code is short and succinct and it's easy to read, and I know what it's doing. And I don't have to sort of look inside this stuff and say, oh yeah, there's a private final field here. Maybe it's immutable or maybe not, I don't know. And you have to keep looking through the rest of class and working out what it's actually representing. So having a declarative mechanism here is a powerful feature. There are other modes of using this AST code generation that don't involve using annotations, but I wasn't going to go into that today. I showed you 4, but there's a whole pile of them, over 80. They can generate lots of code for you. Flicking to another feature, this is an extensible type checker. I've got a date in a string as the first line, and in the second line I've got a regex. I'm going to match that date against something. I'll just check it's a valid date, really. And I've gone and done an error in the regex. All of you eagle-eyed people would have spotted what it is, or maybe the red flag might. There's an opening bracket, parenthesis, but no closing one. So I accidentally left that off. What would I, if I'm doing this in Java or normal Groovy, when do I find this out? At runtime, because there's no typing inside a regex string. But if I put the Groovy's got a built-in type checker for regexes and other ones for format strings and other things. If I apply that, I actually get this at compile time. So I can have stricter static type checking than what Java would give me if I want to. So Groovy's very extensible in that way. So who spotted the missing parenthesis, by the way? Any OCD people? I'm not an OCD person, I'm a CDO person. Do you know what a CDO person is? Yeah. It's a bit like OCD, but all the letters are alphabetically lined up as they should be. Yeah. Now, there's a whole pile of other things that I'm not going to have time to talk to you about today, but there's command chains, which sort of have English-looking like languages. So if you're writing business rules or you're writing SQL queries in a form that it can have code elements to it, which is what your language integration queries give you. There's some really good features in Groovy. There's named arguments, default parameters, ranges, and other things. So you can come back and look at those. So what I want to do now is combine a couple of things that we learnt about and show how we might use that for a case study. We're going to try to do some an application that's going to involve Roman numerals. So everyone knows what Roman numerals are. So I know that all the latest generation don't even know what a digital clock, a clock with hands is. There's only no digital clocks, and the ones that had Roman numerals or whatever, they might have seen Roman numerals in the copyright of a movie or something, but yeah, most people kind of know what it is. So I is 1, V is 5, and if you go VI, that's 6, because you'll add those two together. There's a rule about not repeating a thing more than 3 times, so you don't go V, I 4 times, because to get a 9, you go IX, so 1 less than 10 is how they would represent that. I guess it's a cost of ink scenario, so when you're chiseling into the marble things, your dates or whatever, it's you want to have a smaller amount of things to chisel as possible, maybe. I'm not sure where the rule comes from, but that's the rule. Now, there are libraries out there that do this, so we can just go and grab a library, and this particular one has a formatting helper class. It's called Roman numeral format, and I can go format.parse, pass in a string, or format.format and pass in a number, and it'll print out the Roman numeral, or it'll parse the Roman numeral, give me a decimal. Now that's fine, I can go and do that, but if I'm going to be doing a lot of operations that are involving Roman numerals, I might want to go further. And I'm not saying you always want to go further, but there are times when you might, and let's have a look at a succession of things you might want to do. So the first thing we might want to do is turns out we can use the meta class mechanism to add methods, or we can use extension methods. It'll amount to the same thing. But what we're going to do is hide away the fact that we're using that helper class. That disappears. It's a mechanical thing about converting literals, like strings and numbers, into my domain, which happens to be Roman numerals. So I want to hide away the fact that I'm using this helper class. I might want to use a different helper class in the future, so I hide all that away, and now I can write, it looks like I've got a 2-decimal method on a string, and so I can go xii.2decimal and I'll get 12. So why is this an improvement over what we saw before? Instead of having code that mixes up the aspects of representation and my domain, I've now got code that's just got literals, which I'm familiar with, and I'm converting them into my domain straight away. So I don't see the mechanics. So the code is hiding away some implementation details, and that's usually a good thing. But we can go a little bit further, and what I might do is write a little domain class. I can have Roman numeral. What I put inside here, it can be half this size and have less stuff, but I've put a few things in here. I've got a constructor for strings and integers. I've got a little plus method. Remember we had operator overloading before with plus? So I'm going to put one of those in. I've got a toString that'll automatically do the formatting. So again, the idea is we hide away the library we're using for the munging and the formatting. I'm going to do one little piece of dynamic coding, which is everywhere where this piece of code sees a missing property, I'm going to automatically convert it into one of my domain classes with the name of the property as the thing that I pass in. So that's actually going to be a Roman numeral. Now I can write assert this plus this equals this, and that runs as code, and it's doing the assertion and everything's working fine. So this is where I really want to be, because my code is just all my domain objects. Now the nice thing about this approach is that I've got plus in there. Why don't I add multiply, and I can add in more and more features of more of the operator overloading, or more of other things that Groovy makes use of. Is case for switches and all sorts of things, and I'll be able to do more things. So here I've just added 3 methods in, and now I can have ranges of Roman numerals. I've got a Roman numerals with multiplication. They're in switch case expressions, and they're just automatically working all over the place. Okay. Now I added in an equals method and a compare to method, and I implemented comparable. That's the kind of boilerplate stuff that the AST transforms can do for you. So I can put sortable and canonical on there, and I'll make one other change. So the library we used only supports uppercase Roman numerals. In my little domain class, I'm now going to do a 2 uppercase when I'm doing the parsing. And now all of a sudden I can sort lists of these things. I can use upper and lower case, and again, so my domain's getting richer, and everything's in one place where if I need to go change stuff, if I need to change which library I'm using, it's all there. Okay, now there is some special notations for getting above 3999, but it's generally the biggest Roman numeral, and let's just start using bars and things, other notation. Now why is that? Because to get to 4,000 you'd need 4 M's, and you can't have more than 3 digits in a row. So by design, the library that I'm using, if I type in that expression now using my domain object, it's going to try to convert 4 M's into one of those Roman numerals, and that library is going to say, no, it can't pass that. That's not one of the valid values for a Roman numeral. And this happens at runtime. When it gets the unrecognized property, it's going to try to convert it to a Roman numeral, and it'll have this part. I can just add a little type checking extension, and now I can get that as a compile time error. So you can take this a little way or a long way depending on your particular scenario. Okay, so we've got a whole pile of other things that we could talk about. I'm just going to pick out a few. So Groovy's got some better OO features, and one of those is traits. So I'm just going to give some examples of traits, and then I'm going to really skim through this quickly. I'll try to give you the essence of what I want to talk about. So Java doesn't have extension methods. So one of the things that it's added in, I think it was Java 8, was default interface methods, and later on static methods in interfaces. Now the idea here is that I want to do a rotate method on a list. But Java's list doesn't have a rotate method. It does have a collections.rotate helper method, but I want to have a rotate method on lists. So here's where I'm going to call the rotate. How can I actually achieve this in normal Java? What I can do is create a rotatable list interface, give it a rotate method. I'll just call through to the collections.rotate. Now I can go and create my list, which extends array list, but implements that rotatable list. It'll now get that default method. All of a sudden, I've now got a list that has a rotate method. So this is Java's way of mimicking what we get with our extension methods. And it's all about evolving the Java API. So there's strong reasonings behind the reasons why they've done this. Groovy traits. Groovy you can do the exact same thing that we saw. You can have an interface with a default method in Groovy, and it'll give you the same semantics as what we're seeing on with Java. But Groovy also supplies traits, and traits are a more powerful mechanism. But just to show that it would work for that scenario we just saw, there's the same thing with traits. Traits in Groovy let you share state. They let you be more flexible about selection functionality. It's not just a default that you'll get if everyone else forgets to implement that method. Groovy traits, you can override things by you can bring in behavior and override things. And there's also a stackable traits pattern, and there's runtime traits as well. So here's two traits, and these are stateful traits. Now, Java would say, no, we don't have any state in our interfaces. If you want to have state, you put that in an abstract class. But here I've got two abstract class, to represent these two different concepts, I'd have to mangle them into one abstract class. Here I've got two traits that both have state, and that's fine for traits, for what Groovy will give you. So I'm going to munge those in, and I can now create bosses and players and bring in the behavior that I want. I can have dynamic traits. So here I've got a normal string, and I'm going to go as starable. Starable happens to be a trait. Now my normal string has a starify method, and I can call it. This Groovy lets you, when you're accessing items in an array or a list, it lets you do 0, 1, 2, 3, 4, 5 as a same notation for arrays you can do for collections, but it also lets you do -1, -2, which means go from the right hand into the list backwards. So I want the last, the second last, the third last by using -1, -2, -3. We support that with a get at, one of the operator overloading things that I showed before was a get at, and that's what we support. But if you call .get, which is one of the list methods, we don't override that. We figured let's act more like Java's lists to not give unexpected behavior in certain scenarios. So in Groovy, you decide, is -1, do I want that to reach the last one, or do I want that to be some sort of error? Depending on which you want, you go one way or the other. If you really felt that you want to call get and have the normalizing index behavior, we can do that with a trait. And if we implement my list, which with a normalized get as my list, I can call get -1, it'll return 3. So here I can do an override. This wouldn't work with default methods because default methods won't override the method of the get method out of list. It only gives you the default if no one's defined one. And this is a stackable traits pattern. It's a classic design pattern that Scala promotes quite heavily, and a little bit less so in the Haskell community, but it's the same idea can be done in Haskell. And you can basically have one trait upon another. And the idea is here that each trait doesn't need to know about the ones above or below it in the hierarchy. It just passes things on to the next thing along. So I won't go into any more details. Okay, better functional features as well. Tail recursion and memorization are just two I'll pick out. Now, I'm going to look at factorial and Fibonacci, the two sort of classical recursive things that people sort of look at. Here we're trying to do a factorial, and we're going to try to do, this is in Java, factorial of 8,000, and we're going to get a Stack Overflow error. We do the same thing in Groovy, we'll get a Stack Overflow error. That's sort of showing you what's happening on the stack. It's stashing away temporary calculations of things. I can rewrite the code a little bit, and I can get rid of stashing away of the temporary stuff by basically carrying the accumulator along with me as a parameter, but it still has to remember each time I call into myself, I still stash one execution flow onto the stack, so this will still eventually Stack Overflow. But if I call .trampoline, it basically does a tail recursive things, and I can go up and get 500,000 digits, whatever, not quite 500,000. There's also a tail recursive thing, so if you've got methods in your class that are recursive, you can make them tail recursive. Same thing, if I look at memwise, I'm going to look at Fibonacci. Now, Fibonacci is, it's got order complexity 2 to the n, time complexity, as the upper bound. So what's all that mean? As you get bigger and bigger Fibonacci numbers, it gets exponentially larger and larger and larger. So to calculate 1,000,000 and then 1,000,001, it takes all the time up to, it's double the time to go that one more, basically. And if I do the same thing in Groovy, so how long does this take to run? Well, I only ran 1,000,000th of it or whatever it was, and then multiplied by 1,000,000. So it's 6.4 e⁻⁹ years it would take for Java to successfully calculate the Fibonacci of 100. So that's not even a big number. And so if I do Groovy, it's the same thing, but if I put .memwise on it, then it's 117 milliseconds instead of several billions of millenniums. Okay, and there's a memwise that you can do it on your methods as well. Okay, I'm going to just quickly show you one more thing. And in Java, you have classes and records. So you can write a class like that if you have stuff for free. So it removes boilerplate. That's a good thing. Groovy lets you do the same thing. It supports the exact same notation. Groovy has an alternative form of the notation, which is using one of those AST transforms. And in fact, the record type AST transform is a meta annotation or an annotation collector, and it gets expanded into these. Now, why is this important? Well, in Groovy, in Java, you had to pick, I want a class or I want a record. And if you pick the record, you got everything. It's decided how you're going to have getters. It's decided how you're going to have a toString, et cetera, et cetera. Groovy lets you say, oh, I kind of like records, but I don't like the toString you're giving me or the hash code or the whatever. And you can declaratively mix and match whichever features you want. And I'll show you some examples of doing that. And there is an immutable as well that's defined in the same way, and it mixes and matches slightly different features. And there's a canonical, and so there's lots of alternatives. So why is this a good thing? Well, it means that I can weave in little bits and pieces of this fine-grained functionality as I go along. So records are immutable, but they're shallow immutable. So here I've got a record with a list, and I can go, the list can never change, it's immutable, but I can go and clear the list and add things to the list and whatever. If I go and just weave in the immutable property handler, which is the thing out of immutable, then I'll actually have a deep immutable record. Here, memwise and builder, I can make my records more efficient by doing some of that memwising, that caching stuff that we saw before when we were looking at Fibonacci and factorial. I can write builders for creating things. I don't know, records are very short and succinct and compact. I don't know I need a builder, but if you did, you can easily do that. I can do design by contract. If you were at the TLA plus Clinton's talk yesterday, you could write your Hanoi pre and post conditions and variants and things, all that's designed by contract. Here we've got it on records. I can do at sortable on a record, and now my record's got built into it comparators for each of the record components and a bunch of other stuff. Then I can sort them. Here I'm going to represent the solutions to a quadratic equation. You remember negative b plus 1 is 2, that thing. We can represent all that, and I'm using some operator renaming and some newify and stuff, and it shows me where the roots are to these different equations. Okay, so long story short, Groovy records, it'll emulate records if you're back on JDK 8, and a lot of Groovy's features will work all the way back to JDK 8, or even some of the JDK 22, 23 stuff that's coming out. You can have that on JDK 8 with Groovy. Groovy's got a bunch of extra stuff that you can have in your records as well. You can have a to map, and you can have a dot components and get a type safe tuple of your components, and a whole bunch of other stuff. So it's very feature rich. Okay, same story for switch expressions. There's switch expressions are more powerful. There's regexes and customizable things and closures all inside. So if you're looking at the latest JDK 22, 23 switch stuff, all of that's fine for Groovy in JDK 8 with a very slightly different syntax, and we'll probably eventually support all of the Java syntax for that as well. Okay, so Groovy's going strong still. It's got a much smaller group of people working on it these days than it has at some times in its past, but it's still steadily going along strong. The nice thing about Groovy is we've remained very, very close to Java, so every time there's a new Java version, Groovy just gets a whole bunch of new features and new functionality, and there's almost no work for us to make that work with Groovy. There's sometimes none and sometimes a small amount. And I think it's very extensible is the other thing that I want to keep pushing as well. And I'll make that final point there as well. I'm not trying to, I pitch this as a Groovy thing versus Java, but I'm very much pick the right tool for the job. So I don't think we should be having these wars. We should just be picking whatever language works well. I'm just saying Groovy's got a whole lot of places where it works well. So please consider it as one of your candidates. Okay, and come along to the project if you want to chat more. I think we've got time for a couple of questions. Mike's coming.
We even have a mic. We even have a mic.
Ask Paul on the performance side, like a lot of people are running Java in lambdas and cloud functions in Azure and things like that, and there's lots of different JVMs now you can pick from. Are there, like, with the performance metrics you had, are there like particular JVMs that Groovy works better in, or is it just really whatever Java's good in, Groovy's good in? Has it got some favorites?
Yeah, typically. So if you're wanting to use GraalVM and things like that, so GraalVM converts your bytecode down to native code for you, and it does that by analyzing your code during a sort of a parsing or running an initialization phase or whatever. So you'll basically you'll want to use compile static with Groovy, and then it'll work really well in a GraalVM environment. Is the short answer. So to answer your broader question than just GraalVM, yeah, Groovy will work well wherever Java works well, but in some environments, if you're wanting to try to get onto Android or Minecraft or GraalVM or whatever it might be, you might want to use the compile static stuff. And that'll turn off some of the dynamic features, but it'll basically generate the same kind of code that Java would generate, but with all of the extension methods and other records and other fancy features that we saw.
You mentioned that picking the right tool for the job. Are there any situations in which it would be better to not use Groovy and just use Java?
So Groovy's very easy to learn if you're a Java folk, but if you've got people who have never seen Groovy and you're likely to have teams with high churn rates that you're just going to know Java and you don't want to keep ramping them up on Groovy, that might be definitely a scenario. If you're going to Android, maybe Kotlin instead of Java or Groovy these days. So there's a few different places where you wouldn't necessarily pick Groovy first up. Data science, I'd be picking probably between Scala and Groovy, but depending on if there's certain tools. So Groovy works well with Spark and other tools, but all the tutorials that are on Spark are all Scala based and so on. So if you've got a set of data scientists that are trying to learn how to do data science on the JVM and they want to use Spark, then I can happily show them how to do it all in Groovy, and the code might even look a bit smaller on Groovy than Spark, but you'll find 3 or 4 times as many tutorials using Scala. So it's more about who you're going to have. So there's almost no scenario where I would need to use any language apart from Groovy, but I'm very fortunate that I know Groovy really, really well. Other people that don't know it really well, that's when you need to make a decision. What do they know, and what's the future people that are going to be evolving a code base? What are they going to know, and that sort of thing.